Shall we? Look at this. Oh, okay. There is background noise in my video. Where did it go?
Shall we?
Yeah.
Look at this.
Okay, so hi. All right. Shall we begin? So let's start with this paper. Both of you giving the exams, only one of you is. There are not too many people live right now on this Zoom session. Yeah. But that's how it is. That's how it is, huh? Okay. Let's begin. Okay. So we are looking at what we call the paper in what do you call it? November 2020. So this has just happened a few months ago. Okay. I'm going through the structure paper right now with you guys. Okay. So in detail now. So let's scroll down. This is the first question, and generally speaking, the first questions generally tend to be about knowledge questions about atoms or elements or compounds. Data all across the syllabus they test in the first question. So this is about elements this particular time. And this is common to both IGCSE and O levels. The first question is tending to be about data, information. Not much working, just information. More like recollection. Can you guys not see this? There's something really fuzzy happening, right? It's blur. I don't know why it's in blur. Yeah, why is it blur? Yeah, let me find out. Why is it blur? Yeah, sorry. Yeah, just give me just 1 second. Can you give me a second? Yeah, I can. I don't know why this is blur. Something or the other always have to go wrong, doesn't it? Let me get this to be not blurry. Okay. Guys, I'm back. Sorry. Now you can see the question, right? Now it's visible to all. Yeah. All right. Okay. There's somebody on YouTube saying that the A-level exams are cancelled. A-levels are cancelled? What? Who's... I didn't hear this. I haven't heard this. They're not cancelled, Liza Shah. I don't know. Okay, that's bad news we spread. Thank you, thank you. So let's start now, okay? So this is IGCSE 2020 November paper 41. This is the structured paper and extended. The first question is about elements: aluminum, carbon, iron, hydrogen, oxygen, silicon, sodium, and sulfur. Some of them are metals here. Aluminum is a metal, iron is a metal, sodium is a metal. Sodium is the most reactive among the three, yeah? And you got the non-metals and so on and so forth, yeah? So that's what's going on here. Now, as far as the what's concerned, each element may be used once, more than once, or not at all. It's a very common feature in this question. So if you ever want to revise, if you really want to revise chemistry, you know, you could do question number ones of the last, like, what, 8 years. They go through a lot of theory, just fact-based theory, like cut fast. It helps to revise that, yeah? So amongst all these elements, which can be used as fuel? Yeah? And that's a fun question. Actually, the two elements could be used as fuel, right? There are two elements, because what does a fuel have to do? A fuel has to burn to give me energy. And so, you know, carbon can burn as coal to give me carbon dioxide and energy, and hydrogen in fuel cells can burn to give me water. So both name the element. So they want the name, so you can't even give the formula. So the name is carbon or hydrogen. That's the first. Yeah. So that's well, carbon or hydrogen can be used as fuel. Then name the element that forms an oxide with a similar structure to diamond. Now diamond structure is a macromolecular structure, and the oxide that is macromolecular is silicon. So SiO2 is a macromolecule just like diamond. So the element that does it is silicon. If you're wondering, diamond is like this, where each carbon tetrahedral, and then carbon, you know, tetrahedral, all of these. And silicon does something similar but with oxygen. So silicon, oxygen. Then silicon, each oxygen is 2 silicons, while each silicon is 4 oxygens. 1, 2, 3, 4. 1, 2, 3, 4, like that. 1, 2, 3, that kind of stuff. So this is silicon oxide or silicon dioxide, and this is this one is what you call diamond. So the element that is in this case is carbon, silicon, right? Yeah. You've done this before. So I'm doing the same paper again. No. Can't be doing the same paper again. Okay. All right, crap. Yeah. Okay. Hi. You guys have done this paper with Abul. You know what I just realized? I'm supposed to do ATP with you guys and not structured. Should I switch over to that? Yeah. Hi, people. No, this paper. No, this is structured paper for just like with O levels. Hi, Miral. Should I do ATP then? Or are there any questions you didn't do in this paper that you want me to do? Yeah, I was supposed to do ATP, by the way. I don't know why I wrote this. Okay. This is IGCSE chemistry. Anybody here? So, but I was supposed to do ATP with you guys. Should I do that? Or should I do this? Or did you guys take the ATP exemption? Have you guys taken the ATP exemption or are you giving the practicals? Mm-hmm. Hi, guys. Oof. Well, yeah. Is there much conversation happening here at the Zoom level? Yeah? Yeah, all our classes is on noon on Friday, Saturday. Thank you, Harim. Okay, let's do the ATP. Should I do paper 2? Hmm? Should I continue doing this? And I'll do ATP tomorrow on, or is this paper before or ATP before, Miral? Okay, so till the global warming question. Yes, I found that one. Okay, so let's do the next one. Okay, next part. This is the ATP is first. When is ATP, Miral? Yeah, chain marker. Thank you for being here. I've also been here for 20 minutes. Thank you for your frustration. I'm also been here for 20 minutes, and I'm asking the people in the Zoom class who are with me. ADP is 20th May. And this is when? Do you not know when this paper is? Okay, the next one, organic. Should I do this one then? Or ye kiya tha? Did you guys do this one last time or no? The organic one. Alright. So let's do this one. Okay. So this question is about ethane, propane and butane, a member of the same homologous series. Do you know what a homologous series is? Homologous series is any group of compounds where the consecutive members differ by a CH2 group. So it's a group of compounds where consecutive members differ by a CH2 group. That's the definition, by the way. That is the definition. No, alkanes are not the only functional group. Okay, name this. Oh, sorry. I'm giving the next part. So, state two members of the same homologous series are similar. Oh, I'm giving the. Okay, sorry, my bad. I had the question wrong. This is the definition of a homologous series. So, sorry. Name the homologous series in this case is an alkane. This is an alkane homologous series. And the same way, state two ways members of the same homologous series are similar. They have the same general formula by default. Okay, and they have basically the same chemical reactions. So they have the same general formula and the same general chemical reactions. And the definition of a homologous series is where consecutive members differ by a CH2 group. All right, are two of them. Okay, you could also say that they show a gradation, they show a gradual change called gradation in their physical properties. You know, that's also what they can show. Yeah. So they also have this. One more thing I forgot. One very important thing. They have the same functional group. Members of the same homologous series have the same functional group, the same general formula, and the same chemical reactions. In fact, later on in chemistry in A levels, all we'll care about is the functional groups being the same and the chemical reactions being the same. So these are three of the most important properties common to the elements, or sorry, compounds in any homologous series. Yeah. Then 1 mole of ethane contains this many molecules. So calculate how many molecules are there in 15 grams of ethane. Well, you got to find how many moles is this. So moles is mass over molar mass. So this is 15 over, what's the MR of ethane? Is 30. That's a half a mole. So if 1 mole has this many molecules, half a mole would have half of, or 0.5 moles would have 0.5 times 6.02 times 10 to the power of 23, which is 3.01 times 10 to the power of 23. Yeah? Because this is a mole of particles. So find how many moles is this, and if 1 mole is this many moles is how many? And that's how you get this. Yeah? So far okay with you guys? Then, next up, propane reacts with chlorine. Write the formula of the product which does not contain carbon. Propane reacts with chlorine. So propane undergoes substitution reaction with Cl2. So propane is C3H8 with Cl2. What it does is it replaces one of the H's with Cl and kicks out the H and bonds to the other. So the formula of the compound is HCl. That does not contain carbon. And draw the structure of an organic compound formed. Show all the atoms and all the bonds. So you'll take propane and replace any one of the H's with a Cl. I replaced the last one right here. That's how it happened. So in propane, this was an H, got replaced by a Cl. And this kind of reaction, when you replace something, is called substitution reaction. So this reaction is substitution. Yeah? Abdul Ghani, I did paste the Zoom link on noon, by the way. Alright. Next up. Any questions about this? All clear? Okay. Nope, it is not a displacement reaction. Displacement reactions don't occur in organic chemistry. In organic chemistry, replacing one thing by another is called substitution. Yeah. Now the next question is about alkenes. So aqueous bromine is added to an alkene like ethene. Give the color change. Remember, aqueous bromine is what color solution? Aqueous bromine is orange solution, turns colorless. Why? Because the bromine goes away. And explain in terms of bonding why there's no change. Because there is no reaction. And why is there no reaction? Because ethane is what we call is saturated. ठीक है? Has only single bonds. That is, it has no double bonds. So an aqueous bromine can only react with double bonds. Yeah? Yeah. Then there are two structural isomers with the formula C4H10. Draw the structure of these four. Show all the bonds and all the atoms. Okay, so you got the 4 C's in a line, or you can have the 3 C's in a line and the C in the middle. And then you have H's on the rest of the bonds. This is isomerism, and it's a very popular isomer of C4H10. One is this fellow, which is butane. This fellow is methyl propane. And right there, right there, right there. Why is an isomer? Because in the left one, all 4 carbons are in one long line. Here, on the right, only 3 carbons are in one line, and we call this a branch. So straight chain, a branch. Yeah? That's what we have so far. Alright? Then, what do we have? इसके बाद okay, the next part is butanes formed in longer chain hydrocarbons are cracked. ठीक है? So here they want to show the cracking of butane from C6. So take C6H14, remove butane from it, you get 2 carbons and 4 hydrogens left. So that's C2H4. Works out the formula for the other guy. Yeah? Alright? Should I go to the next page? Okay. So now a compound contains 85.7% carbon and 14.3% hydrogen. So you got to figure out its molecular empirical formula. So how do you do that? You take carbon and hydrogen, you find out their ratios by masses first, and divide by their ARs to find the ratio by moles or amount. And this comes to 7.14 and 14.3. You divide both by the smaller number, 7.14. You get 1:2. So the empirical formula is CH2. Alright? And the molecular formula of this compound is 112. So the molecular formula is CH2 multiple times to give you a mass of 112. So 12 plus 2, the whole thing times x is 112. And this comes out to what? Here x comes out to 14 over, so 14x equals to 112. X comes out to what? In this case, 8. So if x is 8, the formula is C8H16. Yep. Yeah. Yeah, any questions? Do what again, Hanan? How would I do them different? I've given the ratio by mass divided by the atomic mass to get you the ratio by moles. Then simplify by dividing the larger number by the smaller number. You get a ratio of whole numbers. In this case, 1:2. And that means there's 1 carbon for every 2 hydrogens. Yeah? So basically, the molecular formula is a whole number multiple of this formula. So assume that whole number multiple is x. And the whole mass should come out to 112. But the mass of each unit is 14. So 14, and how many 14s do you need to make 112? That's how many CH2s have combined to make the formula. You do the math, x comes out to 8. That means 8 CH2s would give me the formula of a mass of 112. That's how I get 8. Yeah? A good tip is to actually study chemistry. Just study it. You know, without running too much of shortcuts and all that stuff, right? Okay, next up. Then ethanol can be manufactured by 2 different methods. Method 1 is this, method 2 is this. Yeah? Now, method 1 and method 2 is fermentation ethanol. Method 1 is how we get it on the cheap, by fermenting sugar. Method 2 is using steam and ethene that we get from cracking. State one advantage of fermentation. Now, you see, the problem is that sugar is grown, so it's renewable. This is a fossil fuel. So, advantage in number 1 is it's a renewable source, because you can grow sugar from plants. Okay. Yeah. But the disadvantage is that it's a slower process. The hydration of ethene with steam is industrially a much faster process than this. This takes more time, but this is faster if you can control the pressure and temperature. Here it's more like natural conditions. So it's slow but renewable. This is fast but requires fossil fuels, which are non-renewable. Okay? Then ethanol reacts with potassium manganate, which is an oxidizing agent, to form a water and a product. That product is an acid. Ethanol makes an acid. If the 2-carbon acid from ethanol would be ethanoic acid. That's what it would be. And what type of reaction is this? This is oxidation. Yeah? And methanoic acid is this acid. Methanol is this alcohol. So the methanoic acid's OH and the ethanol's H combine to make an ester, which by the way looks like this. The orange part from the acid and the yellow part from the alcohol. And the yellow part is called methyl and the orange part is called methanoate. And draw all the bonds for this fellow on the right is what they want. So that would be the orange fellow, HCO, O, C, H, 3 like this. All right. Okay, give me a second while you guys go through this. If you have any questions, you'll have to wait for a moment to ask me. All right. Okay, guys, sorry. Small problem. I didn't read the question. I didn't read the question. I thought they said methanol reacts with methanoic acid. Okay, sorry. It's ethanol. So ethanol would be, this would be CH2, CH3. You know, that would be, or C2H5. C2H5. And so it will be ethyl methanoate. And you'll need 2 carbons here in the ethyl part. My bad. So the ethanol made ethyl and the methanoic acid made methanoate. So ethyl methanoate. Thank you, Miral. Yeah. Mm-hmm. 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 What else? I think this paper is next part, right? There's the part left. It's not a bad paper, not much too. Okay. So this one is, the table shows what the melting point of ethanol and sodium chloride. If you notice, the ethanol's melting point is quite low, while sodium chloride is quite high. So in one case, what type of attractive forces in each substance? Now you might say, well, ethanol is covalent, so I'll write about covalent bonding. No, you won't write about covalent. It is covalent, but you won't write about covalent bonding. You will talk about basically van der Waals forces between molecules. On the other hand, sodium chloride will be, you can say, attraction between cations and anions in a lattice. Yeah, that's the difference. All right, done with this? All right, what else? So we've done this paper. Should I do a paper, structure ATP paper right now? How about that? Yeah. Maybe Mira is like, Did any exam for you guys get cancelled internationally? Mira, are you based in Pakistan or international? Oh, so your exams are cancelled, no? Structured exams cancelled. Yeah? Isn't it? So you only have ATP and MCQs. Yeah? Oh. And Hanan is not even given the paper yet. So the two people who are in the Zoom class are not even given the exam right now. All right. Okay. So let's do this. Now, what is this, you might wonder? This is 2019 November, paper 62. It's an ATP paper. Yeah. And this is about the first question of this ATP. A student did a single titration to find the concentration of dilute sulfuric acid. Yeah. The student added 25 cm cube of hydrochloric acid, to a conical flask. So if I were to zoom out to show you the whole apparatus, this is the pipette, and that's going onto this. So here you're gonna start talking about a pipette, right? And so PIPETTE, and the other guy on the right is the burette. They want you to name the box of the apparatus. So pipette takes a 25 cm cube, then a burette to get the exact measurement. And basically they're asking stuff like, what indicator would you use here in this experiment? And the indicator we use for normal acid based titration is methyl orange. And if alkali is first and then you're putting the acid, the color of alkali is first, and in a few drops of methyl orange and alkali looks yellow, but in acid it turns pink or orange and red if you want to give the exact colors of the concentrated indicator. But when you put a drop only, then that's what it does. It just takes the the color of the, what am I writing right now? 1 second. 62. Sorry, my bad. Okay. So yeah, you could say or yellow to or pink or orange to red. You could use another indicator, phenolphthalein, which is colorless in acids and pink in alkalis. So if I had used phenolphthalein, then it'd go from pink to acid, and one drop of extra acid is colorless. And what readings do you take when you do a single titration? You'll take the initial burette reading, and what else? And the final burette reading when you stop the titration. So initial burette reading and final burette reading. Yeah. So if the conical flask is not dried but is washed with water, would it have an effect on the value of the titration? It would not have any effect. You know why? It have no effect. Why would it not have no effect? Because the amount or the moles of NaOH added wouldn't change, because the water didn't go in the pipette, it went in the conical flask. And since if the water already exists here and then you put NaOH, The HCl will still react with the NaOH and not the water, so the water doesn't affect. Yes, if you get the water in the pipette or the burette, then it'll dilute the concentrations and the moles will change. But if you put the water in the mechanical flask, it will not really change much because the moles of NaOH coming will not change. The moles will only change if for the volume that you measure in the pipette got some water or the burette got some water. But the conical flask got some water, it would have no effect. Alright? Yeah? Any questions? Just 1 second. Now I'm skipping number 2 to do number 3 right now. This is about salt analysis. Solid P and solid Q are analyzed. Solid P is copper nitrate and tests were done on P and Q. A flame test was done on solid P. The flame test is not something that you have to remember for row levels, but you got to do it for IGCSE. Yeah. So a flame test for copper ions. What flame would you see? You would see a copper flame is what? Okay. If you remember, a good way to remember is copper solutions are what color? It's blue green. So copper basically gives you a blue green flame. Then because it has copper, and then it is added to distilled water which will mix, and then it's shaken, dissolve solid and form a solution of P. P is divided in 3 equal proportions to do 3 tests, 2 in a test tube and 1 in a boiling tube. When you add NaOH to copper, what forms? Yeah, a blue PPT forms. And in a few drops of ammonia to copper also makes a blue PPT, or pale blue PPT. And then the blue PPT dissolves to give a dark blue solution. So the PPT dissolves, and that's a test for copper, by the way, that in ammonia giving a dark blue solution, giving a dark blue solution. Some call it deep blue solution, but it's dark blue or deep blue, same thing. And the third test is a test for nitrates, because test for nitrates is at aluminum. Because what does aluminum do to nitrates? It gives off a gas, which is ammonia, which does what? Turns damp red litmus paper blue. That's what its job is, to turn damp red litmus paper blue. Okay. That's the test for ammonium ion. You need to know your colors for these things. Yeah. And then let me just put up Q also, the next page. So Q has a couple of tests. A flame test was done and a lilac. Lilac is a purple color, right? So what metal gives lilac color? You'll have to learn these flame colors for IGCSE. Okay, lilac is for, you know, anybody? No? Nobody? Really? You have to learn the flame colors then. It is potassium. Sodium is yellow flame and potassium is lilac flame. Okay? Lithium is red, sodium yellow, potassium lilac. Potassium, yes. So this fellow is because of potassium ion. So potassium is lilac, sodium is yellow. So in group 1, you got lithium ion, sodium ion, potassium ion. Potassium is lilac, sodium is yellow, and lithium is red. Yeah. Okay. And in group 2, magnesium is white, calcium is red, barium is green. Okay. And for colored compounds, you know, you gotta do the flame test, like copper color, definitely. You should know it's blue green. Then it says Q is dissolved in water, you add nitric acid, ferric nitrate, you form a cream PPT. Now remember, cream PPT is of a bromide ion. White would have been chloride and yellow is iodide. Cream is bromide. So the compound is KBr, or you can give it a name, potassium bromide. But it's a bromide ion and a potassium ion for KBr. Yeah? Okay, moving on. Done? Any questions? So, pretty, yeah. What? Hey, this is a very small paper. What's wrong with the, 1 second. 62 is a very small paper. That's it. That's so lame. That's so easy. Okay. Yeah. All right. So, guys, Friday and Saturday we'll be doing O levels on Noon Academy. Okay. So you want to practice those? You can come. Chemistry is almost the same. Anybody studying for IGCSE can also get benefit from O levels, and it'll be live streamed on YouTube. So, yeah. But are you guys, Miral, are you studying for other subjects more right now because their exams are earlier? Is that what's happening in your life right now? I want to know what IGCSE kids are doing with their study time, because most kids are not really coming for chemistry classes these days on O levels. So I'm just wondering, okay, what's going on in their lives. Okay. Okay. All right, guys. So ऐसा करते हैं. Let's wrap this up right now. I'll see you guys next on what? Today's Thursday. Tomorrow, same time. This time on Noon Academy's platform and YouTube. All right. Okay. You're all. Thank you. Bye bye. For those of you on YouTube, the thresholds will not vary just because of a pandemic. The thresholds are about the difficulty of a paper. It all depends on the paper, not on the people giving and not giving exams. So the threshold has got nothing to do with the exams, the pandemic. It's the paper difficulty level. All right? All right. Khuda Hafiz everybody on YouTube also. Yeah.